Comprehensive report to CSIS threat analysis of hypothetical BC Ferries sabotage scenario. This report provides a comprehensive threat analysis of a hypothetical coordinated sabotage of BC Ferries, focusing on potential loss of lives and vulnerabilities in emergency response systems. Using precise calculations and real-world data, the report estimates the scale of loss and emphasizes the need for enhanced maritime security protocols to safeguard critical transportation infrastructure. The scenario involves a dual sabotage operation targeting two of BC Ferries' busiest routes, Sawasan to Swartz Bay and Horseshoe Bay to Departure Bay, using sleeper cells and advanced infiltration tactics. The plan includes 1. Sabotaging vessel systems, including communications, navigation, and operational controls. 2. Coordinated physical attacks on passengers and crew. And 3. Disabling Coast Guard emergency response capabilities. The goal of the analysis is to understand the hypothetical loss of lives, the vulnerabilities exploited, and the measures required to mitigate such risks. Annual passenger and vehicle statistics. Annual passengers, approximately 22 million. Annual vehicles, approximately 9 million. Average daily traffic on major routes, around 40,000 passengers daily on peak routes. Ferry capacity assumptions for the scenario: passengers per vessel, about 1,500 passengers on average per ferry. Vehicles per vessel, around 370 vehicles on average per ferry. Crew per vessel, approximately 35 members, including bridge and operations staff. Coast Guard emergency response data: deployed vessels, about 4 to 6 vessels dispatched to emergencies. Crew per vessel, around 8 to 12 Coast Guard personnel per vessel. Total Coast Guard personnel in response, roughly 50 personnel. The hypothetical scenario paints a grim picture of the potential loss of lives. Let's break it down. Passengers on both ferries. The estimated total number of passengers on the two ferries is about 3,000. The cause of this tragic loss? Deployment of carbon monoxide canisters in the vehicle decks, leading to fatal poisoning within minutes. Passengers in their vehicles are incapacitated before they even have a chance to evacuate. Now let's consider the crew members on both ferries. The estimated total crew is around 70. Their loss is attributed to the sabotage of bridge operations, with sleeper agents neutralizing the crew. This includes disabling safety protocols and communication systems. Next, we have the Coast Guard emergency responders. The estimated total number of personnel is 50. The cause of their loss is the sabotage of Coast Guard communication and navigation systems. They are unable to respond effectively due to pre-planted jammers and malware that disable their systems. In summary, the total estimated loss of lives is staggering. For passengers on the two ferries, we are looking at 3,000 lives lost. For the crew members, 70 lives. And for the Coast Guard personnel, 50 lives. This brings the total estimated loss to 3,120 lives. Sleeper cell infiltration, planning and execution. 150 sleeper agents embedded in critical roles or posing as passengers. Infiltration of both ferries months in advance to prepare for the coordinated attack. Key tactics: placement of magnetic carbon monoxide canisters under vehicle doors disguised as maintenance tools, synchronization of deployment to maximize casualties, sabotage of ferry operations, bridge takeover. Sleeper agents disguise themselves as crew or passengers. Simultaneous neutralization of bridge staff using non-lethal but disabling methods such as garrots or blunt force. Systemic disruption, use of C++-based malware to disable navigation, communication, and safety protocols. Pre-planted jammers to prevent external alerts. Coast Guard vulnerabilities, communication jamming. Pre-installed jammers disrupt radio and satellite communication systems. Result: Coast Guard vessels unable to coordinate response efforts. Sabotage of navigation systems. Cyber attacks disable Coast Guard vessel navigation, delaying response times. Key factors influencing fatalities: high passenger density. Peak capacity on major routes ensures maximum casualties if systems are disabled. Delayed emergency response. Coast Guard communication sabotage ensures no immediate assistance. Psychological impact on survivors. Coordinated attacks on two ferries amplify panic and chaos, reducing the effectiveness of rescue efforts. Percentage-based threat analysis. Scenario stage success probability detection risk. Sleeper cell infiltration. 90 to 100% success probability, 10 to 15% detection risk. Carbon monoxide deployment, 95 to 100% success probability, 5 to 10% detection risk. Bridge sabotage, 85 to 100% success probability, 15 to 20% detection risk. Coast Guard disruption, 90 to 100% success probability, 5 to 10% detection risk. Overall fatalities likelihood, 90 to 100% success probability, 5 to 15% detection risk. Cybersecurity enhancements. Deploy advanced encryption and AI-driven anomaly detection systems for SCADA and communication networks. Regular penetration testing and vulnerability assessments of BC Ferries systems. Physical security measures. Implement randomized checks of passengers and cargo on ferries. Enhance training for crew members to recognize suspicious behavior. Coast Guard preparedness. Develop decentralized communication systems to ensure redundancy in emergencies. Conduct joint exercises with BC Ferries to improve response times and coordination. Intelligence monitoring. Increase surveillance of potential sleeper cell activities through intelligence sharing with allied agencies. Monitor recruitment patterns and radicalization indicators online. This analysis estimates a potential loss of 3,120 lives in a coordinated sabotage of BC Ferries, emphasizing the catastrophic consequences of such an event. While hypothetical, this scenario highlights critical vulnerabilities in maritime security and emergency response systems. Addressing these vulnerabilities proactively is essential to safeguarding Canada's transportation infrastructure and public safety. Prepared by Jeff Logue.